Our next function is intarray gather. Intarray gather, which I should have named actually intarray concat, is a function that is going to actually concatenate two integer arrays into one. So we are not going to modify those two arrays here. We're just going to take them, take their content, allocate a new dynamical array which is large enough to contain the data in both of those arrays, and copy the data from both of those arrays into this newly allocated dynamical array. If anything goes wrong at any point with the allocation, for example, we are going to return none. So we have already the prototype cut and pasted in hall.h. Let's have a look at hall.c and start the implementation of this function. So, like usual, let's try to get rid of everything that is error situation. Well, what can go wrong here? If size 1 lesser equal to 0, that's a no-no. I cannot take actually one of those two array. Well, I choose not to take any one of those two array as being with an invalid size. Okay, I could just ignore it and return the other array. I'm not going to even do that. Something is suspicious here. I just stop immediately. Same thing if size 2 is lesser equal than 0. Return null. What else can go wrong? Well, with our experience from array clone, we know that if data1 equal null, okay, which means data1, if not data1, let me rewrite this here, if not data1, then, okay, then return null, and same thing with data2. If data2 is actually null, I'm not going to process this, return null. So we have a bunch of cases already that helped us validate the parameters that were sent to this function. What else? Well, then our main problem is to allocate a new dynamical array. So p equals int array allocate. How many elements? Size 1 plus size 2. And if this didn't work, if not p, then guess what? Return null. Okay. Now, if I am here, that means that, well, the allocation went through. Okay. So I have my new array to play with. I need to copy all the elements. Well, I'm going to use a counter-controlled loop. I equals 0. I lesser strict than size 1 plus size 2. I plus plus. And I'm going to copy my information. So the beginning is going to be easy. P index I is going to be assigned data 1 index I. And I realize here that there is a little, I should name that data 2, there's a little typo in the name of the parameter. So I'm going to go real quick to hull.h and I'm going to fix that typo here as well. The 2 was between the square bracket instead of being in the name. So I'm saving this file again, going back to hull.c and removing that 2 that is misplaced. Save again. Okay. So, resuming back where I was, here is what we were doing. The beginning is easy. For I between 0 and size 1 minus 1, I just copy simply what is in at index I in both P and data 1. Then when I switch to data 2, I would like my counter to be equal to 0 to restart again. But at the same time, I would like I to keep incrementing to store the correct location in P1. So the easiest way to do this is probably to actually break it down into 2 loops. So I'm going to remove this. I'm going to iterate over the first array, I++. It's really important to understand that when I reach this part here, my I value will be size. This is what caused me to get out of the loop, size 1, sorry. So I have now I equal to size 1. I'm not going to initialize it. I'm going to keep this value. I'm going to keep iterating as long as I is lesser than size 1 plus size 2. And I keep incrementing I. So this is going to be good for indexing my array pointed to by P. However, I'm starting at size 1 and I'm going up to size 1 plus size 2 minus 1. However, this is not going to be like so good for indexing my data to array. So what do I need to do? Well, when I start a second loop, I is equal to size 1, and I would like here my index to be 0. So I'm going to take I minus size 1. When I start the loop, this is going to be equal to 0. When I finish a loop, I will be at, the last element I will consider is size 1 plus size 2 minus 1. Let me see, if I is equal to size 1 plus size 2 minus 1, I have I minus size 1, so what I have left is size 2 minus 1, which is indeed the last element of data 2. And when I get over that loop, well, I won't be using this formula at all, I would be out of the loop. So that should be a good first shot, first approximation at trying to actually, assign the copy of this array to my newly allocated array. What do I return when I'm done? Well, when I'm done, if everything went smoothly, I should be able to return the address contained in P. So I'm going to save this file and first compile to get rid of compilation errors. No compilation errors? Okay, now I need to go back to test.c and I need to think about how I'm going to actually test this code. So here is test.c. We are going to add a new function here, a new test function, and this is the gather function that we are testing. I'm going to do like I did before. I'm going to take this and make my my signature out of it. Then I'm going to take my signature and I'm going to put it below here so that I can define the function, implement it. Okay, so how can I ensure that the gather function works? Well, I can start doing what I did for the other function, try to test those error situation. Okay, so I go back to how.c real fast. I need to pass two arrays, each with their size. And then I need to play trying to test if the function will do something actually if I pass invalid sizes or invalid array addresses themselves. Okay, everything else here will be handled by the intarray allocate. For example, if I ask 2 billions size, this is not going to go through smoothly. Maybe this is going to be handled here, but I'm going to focus on testing all of those little error situation here. So I go back to test.c, and I'm going to try to call intarray gather in situation where it should return null. So let me get a temporary pointer here, and I'm going to call int array gather. Let's start with a null first array, size 3. Then I'm going to call it with another array, which I'm going to call a2, which I'm going to define in a second. Size, let's take something different, 6. So, okay, I need two arrays, int a1, size 3, equal 1, 0, 1, 2. And then I'm going to define another array a2, size 6, initialize to, let's start at 3, 4, 5, 6, 7, 8, closing curly brace. Now I have my two arrays that I'm going to test. The first call, use a2, correct size, but provide a a1 array instead of a1, provide null. So this should be a return value of null. So if p is different than null, which means if p, I could simplify that one as well. If p is different than null, return, sorry about that, printf, something is wrong, int array gather with null. I'm going to just put x here because it really doesn't matter. Okay, what matters is that I can identify which test went wrong. So, calling with a null array here caused a problem. Well, let me go ahead and replicate those tests. Int array gather. This time I'm going to pass a1 size 3. And then I'm going to pass null for a2 size 6. And I'm going to test again. If p, printf, error, oops, forgot double quote, error int array gather. Some parameter, null, some parameter. Oops. There we go. And there are a couple of tests here that I can add, okay? So this is going to be like rather boring, but I have to go through the enumeration of possible mess-ups here. We know that 0 and negative for size are handled simultaneously, so I could spare myself the trouble of trying actually both 0 and a negative size. So I'm going to try it with a1, a2. a1 is negative. Okay, so I'm going to notify it here by putting -3. I'm going to assume the other parameters are okay. And then I'm going to cut and paste this again. And you see how this is working. Okay, now if you want to be thorough, you would test like one of them is negative, both of them are negative. Then you would test one of them is 0, both of them are 0, etc., etc. So there are many, many other tests that you can add. Okay, and I will let you add them as an exercise, but I want to give you pretty much a good feeling about what you have to go through to test thoroughly your function. Okay, even for in this video, we're not going to roll out all of the possible tests we could think of. I'm just telling them to you orally. So we have a first battery of tests here. We test if those arrays are null. We test if the size are negative. So then we'd be testing if the size are 0. I'm going to go ahead and do it since it's cut and paste at this point. I'm going to replace this -3 by 0. I'm going to leave the 6 alone. I'm going to replace here by 0. So even though it's somewhat repetitive type of work, you see that you can, once you have the structure correctly, you can get rid of those tests. You can generate those tests relatively easily, okay? And for your information, we're not even using here a real testing framework. We're doing things by hand. So when you are using a testing framework, this kind of stuff can be even easier to generate. So let me see again. We have first array null, second array null. Let's go ahead and do both array null, which we know because of the way we wrote the code. It's not going to be an issue. We could skip easily this, okay? However, when you write the test for code, sometimes you don't know yet what is in the code. Okay, this is called test-driven development. You write the test before actually to write the code. Some other times, the programmer that wrote the code is a different programmer from the one that is going to test the code. This happens quite often. So in this case as well, you would do exactly what I'm doing here. You would push it and you would be like completely null actually to make sure that you cover all possible source of problem, regardless of what you assume the programmer in the code did. Okay? Well, let me see. I think we have like quite a lot there. We tested all possibility for having a null array, all possibilities for having a negative size, all possibility for having a null size. What is left for us to do? Well, what is left for us to do is actually to make sure that all of those cases were supposed to result in a null. So we need to test what happens when we call this function and it actually works, or we think it works. So by think it works, I mean that we call it with a1, size 3, a2 size 6. So we didn't introduce any problem related to the parameter value, and we expect, well, first we expect p to be different than null. So if not p, that means p is null, we have a problem. Printf, oops, printf again, error, int array gather, and returned null pointer. So that will tell us that this particular case failed. Beside having a null pointer, we would expect that the content is okay. How are we going to check if the content is okay? Well, we know the content of our test arrays, right? So we're going to have a third array here of size 9, which we are going to initialize to 0, 1, 2, 3, 4, 5, 6, 7, 8. And we are going to compare whatever was returned to us by intarray gather with this array. So how do we do that? Int result equal intarray compare by position. And I have to refresh my memory on the interface of this little function here. Compare by position is going to take the two arrays and their size. So I'm expecting the size is okay. I'm going to pass P. I'm going to pass at A3, and I'm going to consider the size to be 9, which it should be. Then if, well, what is the situation we want to look for? Result should be, let me check again the interface here. Actually, I will be faster to go in hall.c directly. My comparison will return blah 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 blah, drum roll, will return 1 true if the two are equal, 0 if they are not. So I can go back to now test.c. If result equal 0, they are not equal, well then I have a problem. So I write this if not results, and I do my printf error int array gather produces erroneous content. And that should do. Okay, quite a few tests here in this program. So it should be safe now to save. Let's make sure I didn't introduce compilation error. I did. Line 68, results undeclared. Easy enough to fix. Line 68, if I take the right file, it will be easier. Results plural. Oh, I don't know why I put it plural actually, but it doesn't matter. Okay. Save. Go to Conqueror. Try again. Okay, that was it. Now let's see if my tests are making sense. Well, test didn't trigger any error. The implementation is valid. Actually, I would have to go back, and because I wrote this a little fast, I would have to go back and double check the semantic of every test first, but in this case, I think this code is valid here. So I'm going to put it back on the screen. Intarray, gather, there we go. And we are done with this function in that exercise.